Hello everyone, I hope you are doing well. My name is Mahdi Nazari and I am the author of a recently published paper in CaGIS titled Fine-Tuning Small Language Models for Autonomous Web-Based Geographical Information Systems. I have nearly 10 years of experience in web application development with a particular focus on web mapping and GIS applications. In this video, I would like to give you a brief demonstration of the prototype application developed as the part of our research and show what can be achieved using small language models, or SLMs, in web-based GIS environments. Here you can see the application that was developed to demonstrate the capabilities of fine-tuned small language models. To try the application yourself, you can clone the GitHub repository reference in the paper and shown on the screen, then run the application locally. Once started, it will be available directly in your web browser. The settings panel consists of two main sections. The first contains general application settings, while the second allows you to select and configure language models. Our research focuses on small language models rather than large language models. Small language models reduce dependency on cloud-based AI services, which can be expensive, energy sensitive, and require significant computational infrastructure. One of the key findings of our work is that these smaller models can run directly inside a web browser, potentially on the same device used by the end user. In our paper, we fine-tuned three Google T5 based models: T5 Tiny, T5 Mini, and T5 Small. Within the application, you can select any of these models and load them directly in a browser. There is also a local model directory where you can place your own models. By selecting the local tab, the application can load them directly. Alternatively, the model can be downloaded from Hugging Face, where we have also made our fine-tuned models publicly available. Another tab allows configuration of online models such as Gemini, GPT, and other cloud-based systems. However, these are not the primary focus of our research. Our goal is to explore what can be accomplished using the lightweight models running locally. To begin, I will select the T5 Tiny model from the local. After a few seconds, the model, only a few megabytes in size, is loaded directly into the browser. The application is now ready to use the model for converting natural language commands into structured function calls. This is achieved using browser-based technologies such as WebAssembly, WebGPU, and the transformer.js library. You can see the currently loaded model displayed in the chat interface. The application itself is primarily a demonstration platform. The main contribution of the paper is not a software, but rather than the evidence that small language models can effectively support intelligent interaction within web-based GIS applications. The system also includes voice input. Users can record a speech, which is converted into text using browser-based speech-to-text APIs. In addition, files can be uploaded and referenced within conversation using the @ symbol. Uploaded files are stored locally in a browser using IndexedDB. Next, I will switch to the T5 small model. Although it is larger than the tiny version, it is still relatively lightweight at around 100 megabytes and provides stronger performance. However, one of the most interesting findings of our research is that even the smallest model can successfully perform many GIS-related tasks. Now, let's run a few example commands and see how the system responds. The results may not always be perfect. The application currently supports a limited number of GIS functions, and the training dataset can be expanded significantly in future work. Nevertheless, our objective was To demonstrate the feasibility of this approach and to report the capabilities of small language models within web-based GIS environments. What makes this particularly exciting is that models only a few megabytes in size can perform tasks that traditionally require much larger language models and cloud infrastructure. We believe this opens new opportunities for lightweight and cost-sensitive efficient GIS applications.